We will be using Hasura on cloud for our demo. You can also use Docker Compose for setting up Hasura on local or cloud. We can create free project on the AWS environment. On creating project, we will get the GraphQL API as per the project name. We will now launch the console. On launching console, we will be able to see GraphQL. GraphQL is like a Postman, where we can play with APIs of GraphQL. So now we will connect our to database. For demo purpose, we are using serverless PostgreSQL, that is NeonDB. Once the DB is created, we will create table as per our requirement. For our demo purpose, we are creating patient info table that will have ID. It's in integer type. We will select unique. Other fields would be name, email ID, which would be text type. We have other options to select, like primary key we can select foreign key in case of relationships. Also, we can have frequently used columns like created at and modified at, for which the default value is now. We have selected the primary key as a ID. Also, we can have constraints like we have in normal database tables. Now we can see that patient info table is created. Now we will create vitals table. In vitals table, we will be having ID same as previous with type integer. Other columns would be high BP, where we will specify the count of blood pressure, and our vitals table will have foreign key relationship with the patient table. So we can select it, patient ID with the ID. We can save this. Once we are able to save, we can add table and it will be created. Now, as the table has been created, if we go to the API, we are able to see the GraphQL API is present. So as we have to add the data, we will use mutation type of GraphQL, which is used for data manipulation like insert, update and delete. We will insert sample data, its email ID. Once we insert the sample data, we would run. Once inserted, it has responded like affected rows 1. For viewing if the data is visible, we use query. We'll copy it and open it in other tab. Here in other tab, we will use my query and select the columns. Here we are able we will be using GraphQL features, like whatever columns we require in response, we will pass those only. Now I'll show you other features of query. I'll insert one more data in the table with a new primary key. I'll update the email ID also. Now you can see the affected rows is 1. Once I run this, I'll get 2 response. So I'll change order by from the client side only, like ID, I'll make it descending. Once I run this, the response is in descending order. So there is no code changes required. So we are leveraging the feature of GraphQL. Now we will do a new type of operation. In this, we can have like if we have to have joins from multiple table or some other logics, like we used to create procedures and views, so those can also be created. In this case, I'm taking data from patient table and the vitals table with patient ID equal to the ID in the patient table, where BP is greater than 140. So I'll create a view for this. The view name is vitals info. Oh, there is a spelling mistake. Create. So there is an ambiguity. ID column is in both the table. So I need to specify the columns. Now once I run, you can see a new table is been created. So now I'll insert data into the vitals. Once I insert the data, based on the condition in vitals info, this is backend, you are able to see the data. Now I'll use new feature, that is subscription. So subscription is a feature, it's like a WebSocket in which if there is a data change in the upstream system, the data would be sent to the client. So in our case, the upstream system is database. So I'll make some changes in the DB. So I'll make it to 140. So the condition should fail and the data should get removed. So you are able to see data is removed. I'll pass the condition again, 141. It passes the condition and the data is visible. So GraphIQL acts as the client. You can also export source code from here. If you want to integrate, you can get the REST endpoints for the same. You want to enable cache, everything can be done from here. So other features with the Hasura are actions. Actions can be used for creating custom business logic, or we have to transform our data. So where it can be put, whenever we get the request from the client, we can take the data and send it to the other endpoints. Those endpoints can be REST endpoints or GraphQL endpoints. So these can be used for customization. For remote schema, like if we have, instead of DB, we have other APIs from where the data is to be taken. We can create events. So event trigger is like triggers we used to have in the DB. So it has options like if we have some changes in data in the DB level, then we can call a webhook to the other APIs, external APIs, like we need to call some whenever there is a change, I need to call an mail sending API, something like that. Hasura also provides monitoring, inbuilt monitoring. It will provide overview, error, usage, operations. These data means the Hasura also provide integrations with other observability platforms, so we can integrate with that also. So these are the features available with Hasura. We can have allow list, API list, and also regression tests. Coming to the data, so security point of view, we can have inbuilt security at table level. Like at row level, I want to restrict, I want to create a new role for which it will have only select operations can be allowed. So I can enable that. from security point of view, you can limit APIs and schema introspection.